Welcome to today's ArXiv CS Digest for April 9th, 2026. We received 771 new computer science papers today across 56 subfields. Let's dive into the top picks. Trend 1 of 5, Agentic Multimodal Model Benchmarking. This trend focuses on evaluating AI agents' ability to understand and interact with diverse real-world data and tasks using multiple modalities. This cluster covers 133 papers. Representative work includes Act Wisely, Cultivating Metacognitive Tool Use in Agentic Multimodal Models, ParseBench, a document parsing benchmark for AI agents, and Fail-To Drive, Benchmarking Closed-Loop Driving Generalization. Trend 2 of 5, Inference, Graphs, and Auctions. This trend unifies computational inference from complex data, including graphs, with strategic decision-making in auctions and constrained optimization. This cluster covers 156 papers. Representative work includes optimal DeBiase inference on privatized data via indirect estimation and parametric bootstrap, wideband compressed domain Kramer bounds for near-field XL-MIMO, data and geometric diversity decomposition, and fundamentals of computing continuous dynamic time warping in 2D under different norms. Trend 3 of 5, Multimodal Reasoning and LLM Training. This trend explores how large language models learn and reason across different modalities and data types. This cluster covers 160 papers. Representative work includes Seeing but Not Thinking, Routing Distraction and Multimodal Mixture of Experts, OpenVL Thinker v2, a generalist multimodal reasoning model for multi-domain visual tasks, and meta-learning in context enables training-free cross-subject brain decoding. Trend 4 of 5, AI Ethics and Accessibility. This trend explores responsible AI development, focusing on fairness, transparency, and inclusive design for all users. This cluster covers 142 papers. Representative work includes Ads in AI Chatbots, an analysis of how large language models navigate conflicts of interest. Because we are no longer ashamed of our disabilities, we are proud, advocating and reclaiming next-gen accessibility symbols. And when fine-tuning changes the evidence, architecture-dependent semantic drift in chest X-ray explanations. Trend 5 of 5, 3D human pose and animation. These papers explore generating and understanding human movement and form in 3 dimensions, often leveraging advanced AI techniques. This cluster covers 180 papers. Representative work includes Gaussian animate, reconstruct, and rig animatable categories with level of dynamics, etc. checks, robustify expressive body fitting to clothe humans with composable datasets, and when numbers speak, aligning textual numerals and visual instances in text-to-video diffusion models. Up next, our first paper out of 5, The Detection-Extraction Gap. Models Know the Answer Before They Can Say It by Hanyang Wang and Mingxian Zhu from the University of Chicago. Let's break down its key contributions. We identify and formalize the detection-extraction gap, a structural mismatch where models know the answer early but struggle to extract it. This reveals a key limitation in current generation models. A novel total variation bound is proposed to quantify the mismatch between free and forced continuation distributions. This provides a theoretical basis for understanding the suffix-induced shift. We introduce BE, a black box method that leverages free continuations for both answer detection and extraction. This enables significant truncation of serial generation while improving accuracy. Up next, our second paper out of 5 is your algorithm Unlearning or Untraining by Eleni Trianafila and Georgios Kaisis from Google. Let's break down its key contributions. Establish a clear conceptual and technical distinction between unlearning and untraining in machine learning. This clarifies the overloaded terminology and sets a foundation for precise research. Define untraining as reversing the specific influence of a forget set on a trained model. This focuses on removing the impact of particular data points during the initial training. Define unlearning as removing not just specific data influence, but the broader underlying distribution or concept represented by that data. This aims for a more comprehensive removal. Map existing research efforts in machine unlearning to the newly established definitions of unlearning and untraining. This helps categorize prior work and identify inconsistencies. Up next, our third paper out of 5, MIPT-SSM, Scaling Language Models with $1 Inference Cache via Phase Transitions by Yasong Fan from Independent Researcher. Let's break down its key contributions. Formal proof that norm preservation and selective forgetting are incompatible in a single linear operator. This establishes the theoretical necessity for a novel approach to sequence modeling. Introduces MIPT-SSM, a neural sequence architecture leveraging measurement-induced phase transitions. It dynamically routes computation between wave and particle regimes using a learned measurement rate. A learned measurement rate, $_T$, dynamically allocates tokens to wave or particle modes. This gate enables overcoming the theoretical incompatibility by switching computational regimes. A novel KV cache mechanism that achieves $1 inference memory complexity. It autonomously learns to store only critical tokens, achieving high sparsity and accuracy. Up next, our fourth paper out of 5, Scalable Neural Decoders for Practical Fault-Tolerant Quantum Computation by Andy Gu and Suzanne F. Yellen from Harvard University. Let's break down its key contributions. Introduces a novel convolutional neural network decoder designed to process quantum error correction codes. This architecture leverages the geometric structure of these codes for efficient decoding. Probes a new waterfall regime of error suppression enabled by the CNN decoder. This regime demonstrates that required logical error rates are attainable with modest code sizes. Achieves significantly higher throughput and lower logical error rates compared to existing decoders. This makes fault-tolerant quantum computation more practical and efficient at current physical error rates. Generates well-calibrated confidence estimates from a decoder. These estimates are crucial for optimizing repeat-until success protocols, reducing their time overhead. Up next, our fifth paper out of 5, Theater of Mind for LLMs, a cognitive architecture based on global workspace theory by Wenlong Xiang from Beijing University of Technology. Let's break down its key contributions. Proposes global workspace agents, GWA, as a cognitive architecture inspired by global workspace theory. This transitions multi-agent coordination from a passive data structure to an active, event-driven discrete dynamical system. Couples a central broadcast hub with a heterogeneous swarm of functionally constrained agents. This mechanism is designed to maintain a continuous cognitive cycle within the system. Introduces an entropy-based intrinsic drive mechanism that quantifies semantic diversity. This dynamically regulates generation temperature to autonomously break reasoning deadlocks. Implements a dual-layer memory bifurcation strategy to ensure long-term cognitive continuity. This provides a robust framework for sustained, self-directed LLM agency. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.